Hi, till now we discussed DFA, NFA, how to convert NFA to DFA. Now we'll discuss Epsilon NFA. Epsilon NFA is just a variation of NFA. So NFA having transaction for empty string is called as Epsilon NFA. If there is some transaction on Epsilon, then we'll say it as a Epsilon NFA. It have 5 tuple Q, sigma, del, Q0, F. You already know what are these. Q is set of state, sigma is alphabet, del is transaction function, Q0 is start state, F is final state. Here what is different? Here different is the transaction function. So del Q with alphabet union epsilon. In NFA there was just transaction with alphabet, but here it may be transaction with epsilon, alphabet plus epsilon, and that raised to 2 power q means it may be more than one state. From transaction q with alphabet or epsilon, it will be more than one state. Expressive power of Epsilon NFA, NFA and DFA are same because we can convert Epsilon NFA to NFA and NFA to DFA. Same language can be accepted by all three. E-closure is important for converting Epsilon NFA to NFA. So what is E-closure? If Q is any state in Epsilon NFA, then set of all state that can be reached from Q on Epsilon is E-closure of Q. Or you can say the state which are at zero distance from Q called as E-closure of Q. It can be represented by epsilon star, that means E-closure. So del of Q epsilon equal to Q. Every state is at zero distance from itself. So that's why every state will be E-closure of itself. E-closure of Q is non-empty finite subset of Q because E-closure of Q will be at least that Q itself, at least one state. So that's why it is a non-empty finite subset of Q. Then E-closure of Q0 union Q1 union Qn, that is E-closure of Q0 union E-closure of Q1. So you can find individual E-closure and you can take a union of this. E-closure of phi equal to phi. Then we'll take some example and from that we'll find the E-closure. Let's take a epsilon NFA. There are three states Q0, Q1, Q2. Now we'll find E-closure of Q0. E-closure of Q0 is Q0, Q1, Q2. From Q0 by epsilon to which state you can reach? From Q0 by epsilon we reach to Q1. Then from Q1 by epsilon we reach to Q2. So Q0 itself plus Q1 and Q2, as we can reach Q1 by epsilon and again Q2 by epsilon. Then E-closure of Q1 will be Q1 itself plus Q2. So E-closure of Q1 is Q1, Q2. Then E-closure of Q2 will be Q2 and there is no epsilon transaction, so just Q2 will be the E-closure of Q2. So let's design another graph, another little bigger graph and find the E-closure, that you will get more clear about E-closure. Now this is the graph. Let's find E-closure of Q0. E-closure of Q0 will be Q0 itself plus Q3. From Q0 by epsilon you can reach to Q3. Then E-closure of Q1 will be Q1 itself. Then from Q1 by epsilon we can reach to Q2 and from Q2 by epsilon we can reach to Q0. So Q1 E-closure will be Q0, Q1, Q2, Q3. Then from Q0 by epsilon we are also reaching to Q3. So Q1 itself, then Q2, then Q0 and Q3. So E-closure of Q1 will be Q0, Q1, Q2, Q3. Then E-closure of Q2. E-closure of Q2 will be Q2 itself, then Q0, then Q3. So it will be Q0, Q2, Q3. Then E-closure of Q3 will be Q3 itself and there is no epsilon transaction, so just Q3. Then E-closure of Q4 will be Q4, then Q2, then Q0, then Q3. So it will be Q0, Q2, Q3, Q4, just Q1 is not there. If you have any doubt in E-closure, just ask me in comment. Thank you.